This is section 4.8. We're going to use isosceles and equilateral triangles. So here's a little review of what an isosceles triangle is. An isosceles triangle has two sides that are congruent. Those are called the legs. The side that is not the same length as the other two, that's called the base. Now there are two angles on an isosceles triangle that are congruent also. Those are the ones that touch the base. And that's what we're going to talk about a lot in this section. So these two angles end up being congruent. They're called the base angles. The other angle, this is the angle that's in between the congruent legs, that's the vertex angle. So here's theorem 4.7. It's the base angles theorem. If two sides of a triangle congruent, then the angles opposite of them are congruent too. So if these are your legs, that's your base. These are your base angles. Notice how across from this side is this angle and across from this side is this angle, and those are the ones that have the marks on them. Theorem 4.8 is the converse of the base angles theorem. It tells you if you have an isosceles triangle and you know where the base angles are, then you can identify where the legs are. So if these are the base angles and this is the base, these would be the legs. Those are the sides that are congruent. So again, across from the congruent angle arcs would be sides that have a slash mark. Here's some examples. So your isosceles triangles don't always look like this where your legs are on the left side and the right side. If they do, then those are your base angles. But sometimes you're going to have isosceles triangles where your congruent sides are maybe on the left side and the bottom. When that happens, your base angles are here. These are your legs. Where are your base angles? There. We'll do the same thing with the converse. If you have congruent angles there, these are your legs. If your congruent angles are here, those are your legs. If your congruent angles are here, those are your legs. So in triangle DEF, segment DE is congruent to segment DF. That means these are the legs. So name the legs. That's what we just talked about. So segment DE is congruent to segment DF. If those are the legs, what's the base? Well, the base would be the other segment. So you got segment DE, segment DF. You'd also have segment EF. That would be the base. Now, if that's the base, then you know the base angles. The base angles would be the two angles that touch the base. So angle E and angle F. Name the vertex angle. Well, that would be the angle that's in between the congruent sides. So what angle is in between the congruent sides? Angle D. In this diagram, let's say segment HG is congruent to segment HK. That makes an isosceles triangle here. Which two angles would be congruent? Well, just like that practice slide we did, it would be these two angles. So we'd call it angle G, and don't call it angle K because K is a vertex for a lot of angles. We'll call it angle HKG. Also, I'll switch my pen up here. Let's say angle KHJ, that's this one. Let's say it's congruent to angle KJH. That would be KJH, would be this one. Which sides would be congruent? Well, that makes this white triangle isosceles as well. So your base angles, or your base angles already marked, your legs would live here and here. So we know these two sides are congruent, and this guy's already got one slash mark on it, so these are actually the same length as these ones as well. So segment HK is going to be congruent to segment JK. And we're going to watch. Notice how H is where that base angle comes from. Same thing with J.